Hi everyone, and welcome to the final installment of my podcast series. I have saved a particularly urgent topic for last, one that doesn't always make headlines, but is quietly shaping the future of healthcare around the globe. Today we're diving into the rise of antibiotic resistance, which is also called the emergence of superbugs. This is one of those global threats that feels invisible until it becomes personal. It affects healthcare systems, food production, economics, and ultimately survival. So let's break it down. Antibiotics once transformed medicine. Infections that used to kill people, like pneumonia or infected wounds, became treatable, routine even. But over time, bacteria has adapted and evolved. Every time antibiotics are overused, misused, or left unfinished, bacteria get a new opportunity to evolve defenses. Eventually, they become resistant, which means that the drugs no longer work. This creates infections that linger longer, can spread easier, and sometimes they can't even be cured at all. If this trend continues, even simple procedures could become high risk, and that's what makes this such a global crisis. So what's actually happening? Bacteria are living organisms. Just like us, they evolve. When exposed to antibiotics, the weak die off, but the strongest, those with natural mutations or special survival traits, can live on. Worse, they don't just keep that resistance to themselves. Through something called horizontal gene transfer, they can pass resistant genes to other bacteria, even of different species. Superbugs like MRSA or drug-resistant TB are already spreading in hospitals, and some strains can resist nearly all antibiotics we currently have. This isn't just a problem for one country or one healthcare system. Antibiotic resistance is global, partly because bacteria doesn't really care about borders. In some places, antibiotics are given out too freely, without prescriptions or guidance. In others, people stop taking them early because of cost or access. In agriculture, antibiotics are used not just to treat sick animals, but to also prevent disease and promote growth, which exposes bacteria to low, constant levels of drugs. And of course, with global travel, a resistant strain that develops in one region can spread to another within hours, which makes it everyone's problem. From a biomedical science perspective, this is both fascinating and terrifying. Bacteria can divide every 20 minutes, which means they can evolve incredibly fast. And through horizontal gene transfer, they can literally teach other bacteria how to survive antibiotics. The real problem, though, is we're not developing new antibiotics fast enough to keep up. It can take years and millions of dollars to produce a new drug. And even then, resistance can emerge in just a few years. This is why researchers are also exploring alternative treatments like bacteriophages, which is a virus that infects other bacteria, or precision diagnostics that avoid overprescribing. Let's put this into real terms. The World Health Organization estimates over 1.27 million people died due to antibiotic resistance infections in a single year. That number grows when you include complications and related health failures. It's not just about mortality, it's about how resistance slows recovery, extends hospital stays, and complicates care. The economic cost is billions annually in lost productivity, longer treatments, and more expensive medications. If this continues unchecked, common procedures like dental implants, C-sections, or chemotherapy could carry dangerous risks due to infections. There are solutions, but they'll take a global, united effort. Doctors and patients must use antibiotics more wisely. This means prescribing only when truly needed, finishing the full course, and avoiding self-medication. Agricultural policies need reform too, especially in regions where antibiotics are still routinely used in feed. Globally, we need surveillance systems, research funding, and access to rapid diagnostics. We also need public education because this isn't just a science problem, it's a social one. As a biomedical science student, this is the kind of issue I'll face head-on in my future, and maybe you will too. Here's the bottom line. This is a threat we created, and one we still have the power to control. Antibiotic resistance affects people across all borders, ages, and backgrounds. But if we change our behavior, invest in science, and spread awareness, we can slow it down. This isn't someone else's problem, it's all of ours. It's going to take healthcare workers, scientists, students, and everyday people just like you and me working together to keep the miracle of antibiotics alive. Thanks for watching. I hope it leaves you thinking, asking questions, and maybe even inspired to learn more or get involved. Whether you're heading into medicine, science, or any field, you now know one of the biggest silent threats to global health. Stay informed, stay curious, and always be part of the solution.